Okay, this is Mr. Long, and we're going to move on to two types, or one more type of problem here involving volume and mass. You can think of this as going from volume B to mass A, or volume A to mass B. It really is the same thing. And if we were to look at this, here's your roadmap. So volume B to mass A, you're going to go, first step, you're going to go to moles B, then you're going to use the coefficient ratio to go to moles A, so you're switching compounds or elements, and then you're going to mass A. So that's 1, 2, 3 steps because you're crossing the threshold here. Or you can look at it as volume A going down to moles A, then to moles B, and mass B. They're both the same thing. So maybe you would think better if you went from volume A to moles A to moles B to mass B. Okay, so here's our problem. Let's go ahead and get this up a little bit. And our problem is this. Calcium oxide is used to remove sulfur dioxide generated in coal-burning power plants according to the following reaction. And you guys can pause. You'll need to pause for a little bit and get caught up on these notes here. And here's the reaction. 2CaO reacts with 2SO2 and 1O2 to produce 2CaSO4. So again, S stands for gas. S stands for solid, then we got a gas, and a solid. So calcium oxide reacts with sulfur dioxide and oxygen to produce calcium sulfate. Okay, so this is the bad guy right here, sulfur dioxide. So what mass, so we're going to go to mass, of calcium oxide is required to react completely with 1.4 times 10 to the third power liters of sulfur dioxide? Well, that looks like a mouthful, but it really isn't. So let's look at this carefully. The first thing that bothers you is this right here. Well, if the power of 10 bothers you, let's convert it to regular number. Now, 10 to the third power, it means it's a number bigger than 1, and you can move the decimal 3 places. So you have 1.4 liters, and you can move it 1, 2, 3, add 2 zeros. So we're going to have 1,400 liters. Okay, 1,400 liters of SO2, the bad guy. Okay, now that looks a little bit better. So let's start with what we're given here. So we're given this right here. So let's put 400 liters of SO2. Let's start our process. We know it's several steps. So again, on this first step, you got to have liters of SO2. And that's going to be equivalent to 1 mole of SO2. So again, let's look at that roadmap. So we're at liters, and we need to go down to moles. We're at liters up here. We're going to go down to moles. So we use 22.4 liters of any gas is equal to 1 mole of that gas. That's what we're using in this first step. That's our first step. So here it is, and we're going to put 22.4 right here. Now, in this next step, if you got a cheetah here, you got a cheetah here. So you can have moles of SO2 here, and we want to go to where we want to go, what mass of calcium oxide. So we have calcium oxide here, moles of calcium oxide, moles of SO2. Well, what numbers go here? Well, the numbers in the balanced equation. So look at CaO, you have a 2 here. So put a 2 in front of that. Moles of SO2, we've got a 2 there. Well, that's convenient. Okay, but that's our mole ratio, 2 to 2. And now, so now we are right here. Let's look at our roadmap again. So we've gone from volume A to moles A, now to moles B. So we went from moles of SO2 to moles of CaO. Now we've got to go to the mass of CaO using the periodic table. So let's do this. And here we got 1 mole of calcium oxide. That's going to be equal to grams of calcium oxide. So we've got to add this up. So let's look at the periodic table here. So get out your periodic table. Calcium is 40.08. Let's call it 40.1. And you just have one that's in one atom in the compound. So times 1 is equal to 40.1. And we got oxygen. Well, we know what that is. 16.0 times 1 is equal to 16.0. So you add this up, it's 56.1. So we put 56.1 right there. So what did we just now do? Well, we started with liters of SO2. So we're right up here, liters of SO2. We converted that to moles of SO2. We did that right here in this step. Then we did the mole ratio step from moles A to moles B using the coefficient ratio in the balanced equation, which happens to be 2 to 2. Now in this last step, we're going from moles B to mass B. So when we do that, we can use the periodic table. So on 1 mole of calcium oxide, we got 56 grams, 56.1 grams of calcium oxide. Okay? Put the equal sign there. And what do we do now? We cancel those units. I like doing that. Okay, now we got to pull our numbers over, and the ones drop out. So we got 400 times 2 times 56.1 and divided by 22.4 times 2. All right, everybody get out your calculators, put me on pause, and see what you get. So I'm going to get out my calculator. Okie dokie. And we got this right here. Okay, now we go. So we got 1,500 times 2, and it calculates 2,800 times 6.1 goes to 157,000 divided by 2.4, so we get 7,000 times, I'm sorry, gosh, let me go back there. Shoot. Let me go back. I'm sorry here. Times 2 times 56.1 and divided by 22.4 divided by 2. And we get 3,506. That's a nice big number there. And we're in grams of CaO. Now you guys can check that. We can look at this for a second. 2 times 1,400 is 2,800 times this big number here. So let's look at it times 56.1 and then divide by 22 divided by 2. So we did it right, and that's our number there, 3,506. And we could put that in scientific notation. If we did that, we could say this is 3.506 times 10 to the third power, move it 3 places. It's in grams of CaO. Okay, so this could be your answer too. I would take both these answers. Okay, well there you go. And now let's figure out what kind of problem we can do. So this problem here was our example 13. Okay, we want to do homework 13. Let's see here. Let's do some very simple equation. We can do the formation of water. That's easy. Now when you balance this, we know we're going to have 2 oxygens and 2 over here. And you get a 1 there. Okay. So let's say that how many, let's say, grams of water. So we'll change the conditions. It's not going to be a gas. It's going to be water. How many grams of water can be produced from, let's say we got 2.8 liters of hydrogen gas. So let's make it exactly a bit like this problem here, but it's simplified. So how many grams of H2O can be produced from 2.8 liters of H2? So here we were starting with volume. So again, you're going to go from volume A and you're going to change over to water. You can go from moles A to moles B. Okay, and then you're going to go from moles B to mass B. So you're going to do it just like this problem here. You'll put the liters of H2 here, and then convert this into moles of H2, go from moles of H2 to moles of water, and then moles of water to grams of water. Okay, let's do that for homework, and I'll see you in the next video.